Hey everyone, my name is Rahat. I hope you all are doing well. I am the host of the video series Mainframe Voices. As the name suggests, we are creating a video series where we gather different perspectives of experts on mainframe technology and mainframe modernization. Our goal is to highlight the importance and future of mainframe in today's technology landscape. In this episode of Mainframe Voices, we explore the evolving relationship between mainframes and cloud platforms. Cloud integration has become a significant focus for modern businesses, but is it just a passing trend? Or does it truly revolutionize the way mainframe operate? Our experts delve into the substantial benefits of integrating mainframes with cloud platforms, highlighting how this synergy can drive innovation, enhancing efficiency, and open new opportunities for businesses. Let's uncover how cloud integration is reshaping the future landscape and its potential to be a game changer in this industry.
It is a game changer. It's a real thing. There are organizations today who are doing this integration game where they have the cloud and the mainframe in their infrastructure. And again, I think the key component here is going to be open source software. Making sure that the teams that are running the mainframe and the teams that are doing the cloud environments are aligned as much as possible with the same tools. So everyone's using Ansible, everyone's using VS Code, whatever the organization chooses, that they both work on both environments. And this will help bring the teams together and, prevent these silos of like, oh, that's the mainframe team over there, and this is the cloud team over here. I think making sure that those teams can work together with the same tooling and the same understanding for what the business needs is going to be pivotal. And it has been successful for a number of organizations. So it's really exciting to see.
So I'll probably change a bit change a bit the question to if I'm, and I have customers that are asking this, if I have a cloud strategy and I want to run just on cloud, I don't want to own data centers, why should I keep using a mainframe? And there's probably two or three key things. First and foremost, you can still run mainframes, not necessarily on your data center, and cloud providers do offer things like co-location of things like mainframe services, mainframe machines next to the cloud compute infrastructure that the customers is using. So you don't need to actually have a data center open just to run the mainframe. I think the second thing is, if I'm building stuff on the cloud, how does that work with mainframe? And I think these are complementary solutions. Mainframe requires a simpler application architecture from a technical perspective, because it's everything is running on the same construct, and you have loads of assurances in terms of what you get from storage access, memory access, compute resources access. And in the cloud, it's a bit different. You kind of think of distributed architectures, things may move around, etc. And you need to think through a bit more careful your technical architecture for application, but then on different technical architectures, and then you have business function on top of those technical architectures. And those technical architectures are easy to integrate. I mean, there's loads of ways to integrate mainframe applications and data with the cloud, whether it's through microservices, whether through the event-driven architectures, distributed databases. You can actually do that and have distributed databases that go across mainframe and cloud. I mean, there's specific use cases on where you want to use that, and there's obviously considerations about data consistency and partitioning, etc. But I've come across personally a few cases where you'd have a distributed NoSQL database where have data hosted on mainframe and on the cloud. In certain cases, the data is used from the cloud. That would be kind of a replica. And for other cases, you go back to the mainframe and do certain processing on mainframe. And the data is eventually may be made consistent, which is a fundamental principle of NoSQL distributed databases. So there's quite a lot you can do, and it's not one or the other. You can integrate through applications at the application level, through integration to data sharing, to even database services and cloud distributed cloud databases with distributed data. I think the challenge is because there's quite a few options and there's loads of trade-offs that you need to consider. Not everyone is successful because there's quite a lot of architecture thinking to be done. And when you choose a solution just because it's new rather than because you understood your problem and you found out the best way to solve this problem, then that's when things go wrong. I've, again, in my experience, come across a couple of years ago when Kafka popularity exploded. It's a great solution. Event-driven architecture is really powerful, but you need to think about the use cases and use it well. And I've come across some customers that try to implement it in anger across everywhere, inclusive where it didn't make sense, and they just start complaining about technology. It wasn't the technology. The use case that you're trying to solve would be fine with just traditional message bus integration. They didn't really need to put a complex thing like event-driven architecture supported by Kafka in the middle. So it's about thinking what you need to integrate, what use cases, and different options that you have at your disposal. That's what makes a difference to be successful.
That's a big question these days. And you look at the general idea behind cloud computing is, that your IT resources, your computing power, your database, your apps, your storage are delivered by a service provider, and it's over the internet with a pay-as-you-use pricing. And the cloud provider is going to host those resources, and you access them over the internet using APIs. So you contrast that with the traditional on-premises, purchase, install, maintain the hardware, maintain the software, pay the providers when you buy the software. And instead, you're paying the service provider to host it and give you access as you need it. So hybrid cloud computing is really something that IBM really started to push, and I think it's a buzzword in the industry because IBM helped to coin it and promote it, and rightly so, because what it does is it gives you the benefit of on-premises mainframe computing, and that over the course of decades we've proven is reliable, substantial, performant, and all these things. But also integrating the cloud computing, which offers quick scalability and your ability to ramp up and move forward. So really what I see with hybrid is this polyglot approach where you implement workload on premises and in the cloud where it makes the most sense in the way that your organization can adopt, ingest, manage, and use each specific platform. So, in a way, when I look at cloud computing, I don't see it as anything that really should be viewed as a colossal change. It's another platform. It's someone else's computer that you're running something on. And one of the things that I think is dangerous is a misunderstanding of what cloud is. I talked to lots of different organizations, and some of the vendors previously were selling outsourcing services. It's like, you don't need to manage your mainframe anymore. We'll put all your applications on our mainframe and run them here. Now they're trying to say that you do that and it's the cloud. It's not. I mean, it's another option for running your hardware. And yes, it is not on your computer, it's on someone else's computer. It depends on whether it's single tenant, multi-tenant, on just how much of you own the hardware versus they own the hardware, and all these issues come into play. But with the cloud, it's not just here's where we're running it, it's also here's how we're accessing it. It's the API access to it over the network to get to it in the cloud. So the combination of the two makes an awful lot of sense. There was, I'm going to go back 4 or 5 years ago, and the analysts were saying, by the 2022 or something, everything will be running in the cloud. Here's my rule of thumb. Anytime an analyst says everything, they're wrong. In this case, they were really wrong, because if you look at just the mainframe world, shut down every mainframe, convert all of the applications into a cloud-based architecture, and have everybody access those applications via the cloud. Now, right there, the workload is tremendous. You're not going to do it in a number of years. You're not going to do it in a decade. There's so many mainframes out there with so many applications built from the 1960s to 2024 that you can't conceivably think of changing and migrating them all into the cloud. On top of that, you're not running COBOL in the cloud, right? You're probably running Java in the cloud. Convert COBOL to Java. There are companies out there that do that, but it's not easy. And all of that aside, how much bandwidth do the cloud service providers have to take on everything that we just decided we couldn't conceivably convert quickly? Assume we did. Now, all up in the cloud by 2022. Didn't happen. Not going to happen. Not going to happen by 2032. So we need this hybrid approach where some of the newer applications that we write run in the cloud. The older ones are still going to be running in the mainframe. And we're going to need data integration, application integration, and APIs that can understand both types of architectures and deliver productive information to end users of applications in both environments.
Question that doesn't have an easy answer. Clouds are effectively outsourced infrastructure. So when you don't have one, like infrastructure at all, then starting with cloud and just using it is easy. So what it did is that it enables a wave of innovation based on the fact that it's cheap and easy to start. This wasn't the case with on-premise infrastructure, regardless of what type of infrastructure you are looking for. On the other hand, when we are moving into larger and larger scale efforts and solutions, it's just outsourced infrastructure. And it has all the good parts and all the bad parts of outsourced infrastructure. So it's hard to say whether it's great or not. For industry overall, I would say it's just another way how to approach things. And there are use cases for which it's great, and there are use cases for which it's really terrible. And it really depends on what specific use case you are looking for. And you can see it in companies coming to the mainframe, to the cloud, and leaving cloud for on-premise. And some of them stay in the cloud and are very happy with it because they do have use cases that are really for this. What I would say is that mainframe environments are really good if you have a baseline workloads that are more or less stable or growing by reasonable amounts. That doesn't really have too much peaks. And then you can get to very low cost of processing. And on top of that, we are now in the age where we do care about the green and about the environment impact. And the ZOS and the mainframes, the hardware can have a far better environmental impact than the traditional x86 data centers. So I think that both of these machines deployment models have its space. I think that the companies want to be fast and they don't want to have a separate silo of experts on either place. So whether it's Google, AWS, Azure, or mainframe. So if we want to make sure that mainframe stays relevant, and I think we all do, it needs to be accessible in a similar way so that the enterprise ITs can just incorporate it as one platform in their overall strategy instead of making sure that it's something else, which means that it's easy to start, it's easy to ramp it up, it's easy to ramp it down. But on the other hand, I wouldn't say that they are as effective in managing the costs when you are talking about something that's more or less a stable workload.
I believe, especially with IBM right now, that they are promoting hybrid cloud, which is like there's still an on-prem part for mainframes and there are cloud stuff that they move to the cloud, which I think is a good thing because now, as well, I think that's the trend with modernization today. You always hybrid that there's still mainframe things, but you're covering it with Zoe or you're covering it with VS Code, and it's the same with cloud. And I don't think it's just a buzzword. I think there are use cases where you can use cloud for some of your processes, and you can use on-prem, especially for, let's say, batch processing or something that's very, very important that involves money. You can use the batch processing or on-prem, and for other things, you can use the cloud. So yeah, I think it's not just a buzzword, but they are actually implementing these kinds of things. I'm not very familiar with it, but there are very useful use cases regarding this approach.
So your question was about cloud computing and if this was, what was the synergy between that and mainframe computing. So it's interesting. I mean, cloud cloud means lots and lots of different things, right? So one of the things that cloud means is you can just basically, you're just renting space on somebody else's computer, okay? And that's really useful. Like sometimes I need to create an environment, and I'd much rather just go and provision something in the public cloud and do something and then tear it down. You can also provision, infrastructure and then deploy your applications onto it. And often you get what's called software as a service, right? So if you just want to run a piece of software, you just go to the cloud. And the cloud is very, very good at what it does. And it's created lots of incredible companies, and there's lots of amazing companies. Their entire infrastructure is based upon the cloud, right? Like Spotify and Netflix and things like, video and music streaming companies. And a lot of banks and insurance companies that use the IBM Z mainframe platform have a huge cloud footprint, right? And they have a huge deployment. And that's going to be for in terms of edge computing, right? You want to put those workloads, put those servers close to where those customers are. So when you travel around the world and you're a customer of a bank or something, and you need something that's got very rich in user interface, very rich UI, perhaps it's written in JavaScript or something like that, that makes a lot of sense to just run that in the cloud, right? In the public cloud. It makes an awful lot of sense to just rent that infrastructure from whoever is the cloud provider, or whoever can give you that sort of local footprint, right? So you have a very short kind of hop to that user, and you can meet the regulations, and perhaps you have a relationship with a, mobile phone company in that geography, or an IS internet service provider or something like that. But when it comes to the system of record, the data that ultimately says, well, now I'm going to make a transaction. Now I'm going to make an acidic transaction because I'm going to move money between bank accounts, or I'm going to move the purchase of a particular product, or airline tickets, right? They're all ultimately backed by mainframes, right? Systems of record by governments and things like that. So you have this hybrid topology where clouds and mainframes play very, very well together, because at the end of the day, if you go somewhere and you try and make a payment and just goes, oh, it timed out and it doesn't matter, you're just like, oh, whatever, I'll just log onto a different network, or I'll try it again, or I'll try a different vendor to buy that particular product. But when it does work, when all of that infrastructure does work, and you need to know it worked and record it worked, you have to have that with a computer that won't go down, that you can guarantee you can have backups for it, and provide disaster recovery, an incredible amount of uptime. And so often people talk about the system of record, and the system of record is where the mainframe does really well. So a lot of customers I talk to, there's nothing anti-cloud about mainframe, and there's nothing anti-mainframe about cloud. The two do work very, very well together.
And I'm no expert in integration. I'm learning about the area more as we go through at the moment. I think for me, the ability for someone that it works on the mainframe to access data sources and applications that are not part of their team has been really key. So things like ZOS Connect that allow open API standards to move between the platforms has been revolutionary in the industry over the last 5 years. I think the ability to talk between platforms is a must now. It's not oh, we might want to do that. It's we have to be able to talk between these platforms. I was working with a user or a customer a while ago on how they were bringing data out of their system, and to be able to print digital receipts for their users in a shop. They were in a grocery shop, and for them, they were using Tecton pipelines and IBM Cloud and all of that great fancy stuff on the front end, but they were calling data sets at the back end on the mainframe, and they use ZOS Connect to do that. And so I think it's scenarios like that where it's a must. You have to be able to take the information that's sacred in data tables and with SQL requests into the cloud and applications where you can email it out to customers, and it's really easy. So scenarios like that is absolutely, it's more than important, I think. I think the second thing is around how someone that sits in the world of creating applications on the cloud, how do they talk to the mainframe? So it's like the opposite scenario. How do they get information and how do they get data? So a good example of that is What's Next Datagate, which got announced a couple of months ago. And that's all around creating an easy, like a carbon interface into the mainframe so that you can go and get data. And you don't need to be able to access the mainframe, green screens, anything like that. You can just give them the specific data set that you want and it will grab it for you. And you can do analytics and really cool things on that. I think from my perspective, it's broadening the amount of information that you can get from the mainframe and the people that can access it. I think that's what's really important. And for me, the ability to open that up to more standard interfaces in the way that open APIs do, in the way that ensuring that the people that are developing on the cloud aren't scared of the mainframe, I think is super important.
The mainframe is basically your crown jewels, and you don't sell your crown jewels. It's like a lot of companies were really into outsourcing when other markets opened at a cheaper rate than what was available in their home market. And then when cloud first started to appear, it was all the rage. People who've worked on the mainframe for decades realize its importance, and you don't just shift everything off the mainframe up into the cloud. You don't get the performance, you don't get the security. Just recently, there was this company who shipped everything that they had up into the cloud. And because of an error in administration at Google, they were using Google Cloud, their whole account was deleted, and all of their data was deleted. And that wasn't their fault. It was just a configuration error, and the whole, not just the backup, not just the live data, but the backups as well. The whole account was accidentally deleted. That company lost a lot of business and a lot of time just backing up, going back to the backups that they had. Stories like that are few and far between. But where the mainframe sits, you have a brilliant opportunity for a hybrid cloud situation where you've got your own on-prem data center running with mainframe protecting your data, but you've also got a cloud infrastructure that you could use backups for. For example, I know BMC Software, we have a product we call BMC AMI Cloud, which basically is a product which plugs in cloud deployment in your JCL. So you could have something like you could back up your DB2 image copies with in your DD statement of vol_cert equals cloud, and then that would, or dev type equals cloud or something like that, and it just goes straight through the software and puts the image copy into your preferred cloud provider. So I'm a firm believer in the 3-2-1 principle of backup. Have 3 backups on 2 different media, and one of which is offline. And what better location to have your offline image copy or backup than the cloud. So the cloud is definitely not going away. My personal opinion, and others' opinions might vary. My personal opinion is you don't stick everything up into the cloud. It's brilliant for backups, but you still want to keep your critical mainframe systems locally.
So when we're thinking about open source and we're thinking about the OpenShift platform, I can run it in your favorite cloud. I can run it in my on-prem cloud environment. I can run it on Z. And so it makes it a standard way of working across all of the environments. And so from the standpoint of workload, you can move it where you want to. We think about more traditional ZOS work, and we think about databases and the fact that huge percent, 70, 80% of structured data is still sitting on Z. You want to access that data. So all of the different techniques to integrate data access via APIs, via virtualization, allow you to take advantage of the data without necessarily moving it. I can just connect to the system, and so I can interact with the data that I have in combination with other unstructured data that may be somewhere else in cloud. And so bringing that together, that integration is absolutely critical as we move forward. And that's one of the ways people use Z and cloud together. But we also have to think about when people first started talking about cloud, the purpose of cloud was to get cheaper, or the perception would be, I'm going to save costs. But you don't necessarily save costs moving to the cloud if you're a large company and you're going to run the systems for a long time. I mean, if I'm going to run it for years, many times it's more efficient to run it in my own environment. But it really does depend. CapEx, OpEx charges, it depends on finance charges and the way you look at things. But really understanding, are you going to cloud for flexibility? Are you going for cloud and treat your Z as just another part of your cloud and have it all integrate together and run the work where it makes the most sense? And by using things like OpenShift so that you really truly can deploy it where it makes sense, accessing data from Z through standard integration methods ensures that you can keep data secure, but access it from where you need to access it.
Mainframes are expensive and old, and you cannot get young talents who are interested for that. Therefore, they want to reduce the code on the mainframe more and more. The difficulty is that you cannot move away the backend stuff directly, especially DB2 cannot be replaced directly because it has got special features for COS which cannot replace anywhere. The same as also with some SIGs and batch programs. Therefore, if you want to test the programs in the cloud, you should start with the front-end stuff because that is not related to any transactions or something like that. Therefore, it is easy to move the front-end applications to the cloud, but keeping the connection to the mainframe continuously. There are special services in the public cloud. AWS is a good IBM partner, and you can use AWS S3 as a data storage together with CloudFront as an example, and then you can come closer and closer to the backend stuff. But anyways, you should keep the transactional processes on the mainframe because you cannot replace it there in the cloud. That would be too expensive. The future of that is that the public cloud providers want to provide also mainframes in their cloud in the future, equal to IBM is doing at the moment, but that would be more expensive than having an own mainframe in the data center.
It is a game changer because the innovation in certain fronts, especially with data analytics, is very fast on cloud. Mainframes, they can handle transaction systems very well. They are stable, they are fast, they can handle it extremely well. As I said previously, the open source thing, right? The contribution from the number of people that happen in mainframe is less for innovation. But on the open source right now, on the cloud side, it's more. So there are more organizations that are developing new tools, and those tools are growing up in functionality that organizations can take advantage of. So in cloud, those capabilities are being developed pretty rapidly. So a smart organization rely on both technologies. So they should know how cost effectively they could integrate two different things and take advantage of both because both are available for them. So the cloud technology, again, any smart organization will integrate both and they'll be very cost conscious and they'll get benefit out of both worlds.